So last time I'm going to start with alkene. Just give you a brief overview. Alkenes was, I told you that it was a carbon that was sp2 hybridized. ठीक carbons electrons getting pulled in three different directions. One electron, which is your p orbital, that's unused, and two carbons would overlap, and they would make three sigma bonds. And the p orbitals would overlap in the middle, and they would start forming a pi bond, and the pi bond is going to have a very high charge density. There's a lot of electrons over here, very concentrated, ठीक and so there's a very high electron charge density, which is why when you see a double bond over here, it attracts electrophiles very, very strongly. So alkenes always had reactions that were electrophilic, and they always had mild conditions. For example, if you know, most of the time you didn't need any help. You had a double bond, the charge density was very strong. It would knock out the electrons from the molecule, and it will attract the positive side and repel the negative side. So it will polarize the molecule all on its own. The double bond would have such a strong negative charge that it will attract the positive part of the molecule and repel the negative part of the molecule. And therefore, you had strong electrophilic reactions, and most of the time you didn't need any help whatsoever. अच्छा वो क्या था कि when you have this thing, which is benzene had, you could think of benzene as having alternating double bonds. Except for the fact that the double bonds, they eventually get mixed up. So in benzene, all carbons are exactly the same. They're making three bonds, and the fourth electron is not involved, but it eventually ends up forming pi bonds. But benzene, two of the p orbitals would overlap, they'll form pi bonds. Two of the p orbitals would overlap and they would form pi bonds. Two of the p orbitals would overlap and they would form pi bonds, except that at the end of the day, they would all start overlapping. The middle ones, they would start overlapping. All of them would start overlapping. And as a result, you had a huge pi electron cloud, but it didn't have a very high charge density because the p orbital not only is overlapping on the left, it's also overlapping with the p orbitals on the right. So the electrons are kind of more distributed, okay? They're more distributed. तो उसकी वजह से क्या होता है, the charge density is not very high. You don't have a very high charge density. And so unlike a normal double bond, benzene's pi electron cloud has a lot of electrons, but they are not very concentrated. They're not very effective. तो हम benzene पे आए थे. This is what we were doing last time. An electrophilic substitution of benzene. You can remember this, that it's one of the most important reactions that you're going to study in A levels, and you'll be asked a lot of questions about this. As a benzene also has a pi electron cloud, the bromine molecule comes in. The bromine was supposed to be polarized because the electrons over here, they should repel the electrons in the bond, but they don't. And the reason is that the electrons, this p orbital is kind of overlapping on both sides, so its charge density gets distributed. So it doesn't have the same repulsion power. So it tries to push the electrons, but the bromine doesn't really get polarized a lot. So the reaction doesn't happen. The positive charge would not be very strong, the negative charge would not be very strong, and therefore the electron cloud will not attract the positive bromine that strongly. So you don't have a reaction. So what you need to do is you need to add a catalyst because you need to increase the polarization. So iron is a very good catalyst. So on one side, the benzene pi electron cloud is trying to push the electron, and on the other side, it's the iron that's trying to form a dative bond and trying to attract the electrons. ठीक है, वो transition metals याद करो, उसके अंदर यही हो रहा था कि the cation was trying to attract electrons and form dative bonds. तो ये clear है? Is this clear? Minal, Isaac, Umar, Ibrahim, is this clear? Qasim, clear है?
Yes.
Yeah, so benzene has a pi electron cloud, except that its polarization is weak, which is why you need an iron as a catalyst. FeBr3 is a catalyst. And the next step is I told you that the positive Br will come over here and will start attracting the p orbital and start bonding with it. Okay, the positive Br is going to do that. And that is exactly what it does. So your p orbital goes missing. I mean, the p orbital which was overlapping on both sides, ठीक है, नीचे भी, the bromine over here, the positive bromine came and took that electron. So your benzene pi electron cloud is now kind of partial because this bromine took the electron, and therefore this benzene pi electron cloud is going to be electron deficient. It's going to have a positive charge. And where did the Br minus one go? The Br minus one ended up forming a dative bond with Fe. So this is the same picture, Malay. So this is exactly what's happening. Negative Br goes to Fe, positive Br goes to benzene. ठीक है, ये clear है? Ibrahim, clear है?
Yes, sir.
Achha, and that's it. So now the last step is that the benzene electron cloud is electron deficient at the moment. So it needs its electrons back. So what it does is that it takes electrons because Br took the electrons. Now H over here will sacrifice its electrons and give its electrons back to the carbon so it can form the pi electron cloud back again. And where would the H go? The H, on the other hand, will take the electrons from Br. H will become positive, and then it will go and attract the Br back again, and it will form HBr as a result. So the next step is, I'm just going to copy everything. Okay, so this whole thing is, as I remember, I'm just going into a bit more detail over here I'm going to do a simplified mechanism as well. Achha, so the H gives its electrons back to carbon over here. And what do you get? The carbon gets its p orbital back. And what is that? I mean, sorry, screen नजर आ रही है सारों को?
Yes, sir.
चलो ठीक है. अच्छा खैर, उसको carbon gets the p orbital back, and there would be pi bonds getting formed back again. ठीक है, so these are your pi bonds forming. This would also overlap over here. And these would overlap. ठीक है, so इसको छोटा भी कर लें. ओके, ठीक है. अच्छा, so the benzene electron cloud is now complete, so the positive charge is going to go away. It got its electrons back. So removing the positive charge in the middle. Where would this H go? The H will take the Br and bond with it. The H is +1 now. So this H will then bond with and pull this Br back. And the catalyst would reform. It will again become FeBr3. So it again forms FeBr3. So yeah, it's a not that difficult. It's a simple mechanism. I'm going to do the simplified version now. The reason is you need to know a detailed version. Why? Because they might ask you why the bromine is not getting polarized. Well, the benzene pi electron ring has low charge density. So less polarization that I'm going to add. Less polarization for Br2 molecules. So anyways, the simplified version of this mechanism is you've got benzene, and this is the electron cloud. Here's a Br2 molecule. Here's the Br2 molecule. And then you have an FeBr3 catalyst. Arrows, draw the arrows. The electron from benzene are going to go towards bromine. And these electrons are going to get repelled. This bromine will become slight negative. This bromine will become slight positive. But the polarization is not going to be very high. So the Fe on the other side will also attract these electrons. So the bromine could be polarized further. So next step is the formation of the benzene ion. So this bromine over here takes its electrons and bonds with Fe and forms a dative bond. The other bromine goes and bonds with benzene. So basically what it does is it bonds with one of the carbons, borrows its electrons. There's an H already bonded to it. And this pi electron cloud becomes a partial. So it's not going to be present on the carbon atom where the bromine attaches. And the benzene electron cloud is going to have a +1 charge. As if the next step is that the H will lose the electrons. So we need H to lose electrons. So I'm going to draw the H will give its electrons back to. So it's going to give its electrons back to benzene. Br is going to come from the other side and bond with this H. अच्छा plus ये वाला जो FeBr has a -1 charge. So it's got a -1 charge. And so your final step is the benzene becomes full again or complete again. जो BrH has bonded with Br as well. And you are back to FeBr3. And that's it. ठीक है, so step 1 and step 2. So that's your entire mechanism. This is how you're going to draw in your exam. ठीक है, is this clear?
Yes, sir.
Yes.
So ये थोड़ा detail है, ठीक है. It's so I just drew one detailed mechanism, and so that's your detailed version. Bromine getting polarized, but not enough. FeBrC catalyst is needed for further, either add कर लेते हैं, for further polarization. Otherwise, the reaction will not happen. Bromine steals electrons from benzene, benzene becomes an ion, and the other bromine goes and bonds with FeBrC, the catalyst, and then the H is the one that's going to. So that's why it's substitution. The H is the one that loses electrons. इसको सीधा कर लें. And that H forms HBr. Again, that's your entire. Now, all electrophilic substitution reactions are going to follow the same kind of mechanism, which is so you basically have to memorize this, every single thing about this, every small detail. It's got to be memorized. So step 1, step 2. So now, so I'm going to write a summary of this, which is कि हमने directly issue कर दिया electrophilic substitution of benzene. So I'm going to write a summary of the reaction. So summary of bromination or chlorination. We did the mechanism. I said, remember, इसके अंदर ना A2 में you have to be really good at making benzene. You would have to draw benzene a lot of times. I said, I'm just writing the summary, which is that you add Br2 and the reaction would happen. And normally what will happen is one Br gets substituted. So normally there's going to be one Br and HBr molecule. Okay. And the conditions are that you need either FeBr3 or AlBr3 catalyst. Okay, that is required. And the same is going to be for Cl2 as well. So exactly. The Cl2 में the only thing you got to change is so instead of FeBr3 or AlBr3, it's going to be FeCl3 would be the catalyst or AlCl3 would be the catalyst. You'll add Cl2. And over here you will get, instead of Br, you're going to get Cl. Instead of HBr, you're going to get HCl. ठीक है. अच्छा, प्लस इसमें अच्छा एक चीज, सॉरी, हीट का मैं वो एक सेकेंड, लेटेस्ट सिलेबस में आई एम जस्ट गोना कंफर्म वन थिंग कि रिक्वायर्ड है कि नहीं है. जस्ट गिव मी वन सेकेंड. नहीं ठीक है, that's enough. ठीक है. अच्छा, so ये clear है इब्राहिम? Middle, Isaac, is this clear?
Yes, sir.
Yes.
अच्छा, next one, it's going to be exactly the same. The next one is that we're going to do again electrophilic substitution, and this time it's going to be nitration. So second one is, it's again electrophilic substitution. Again, it's going to be called nitration. So benzene is going to get nitrated. ठीक है, तो somebody end पे लिखते हैं first the mechanism. Now the mechanism in this is, you have to write the reaction first. So I've got benzene. ठीक है, that's the benzene electron cloud. And what I'm going to do is I'm going to react it with instead of, there's just an arrow. And the reagent is concentrated nitric acid. And the catalyst that's going to be added is concentrated sulfuric acid. Plus, the temperature is going to be kept around 55 degree centigrade. And what we're going to get is that this benzene over here, इसमें ना एक NO2 आके ना fit हो जाएगा, ठीक है? There's going to be an NO2 that will come in, and that NO2 will attach over here. That's it. Here, that is nitration. So all of a sudden in benzene, you have an NO2 that is sticking to one of the carbon atoms. And it's substitution. The NO2 is the electrophile and it comes in. This case stages जो है, step number one. Step number one is, in step number one, the electrophile is produced. Here, that's step one. How is it produced? That's the nitric acid. And you have to remember this equation, nitric acid and I think 2 sulfuric acids, H2SO4, they react and they produce the NO2 plus 1 electrophile, nitronium ion, plus 2HSO4 minus 1, plus H3O plus 1. इसको देखो कि is it balanced or not. It's 3 oxygens plus 8 oxygens, so that's 11. 2 plus 8, that's 10, plus 1, that's 11. So hydrogens, that's 4, or 1, that's 5. So वहाँ पे 2 plus 3 here, it looks balanced. So this is the reaction in which your electrophile is produced, which is this one, the NO2 plus electrophile. ठीक है, that gets produced. ठीक है, electrophile आ गया. Now, if that gets produced, so what does it do? It goes and does exactly the same thing which was happening in the other reaction. Okay, you're going to have benzene. तो ये आपके पास benzene है. And you have a benzene electron cloud. The NO2 plus 1 is going to come in. And it's going to attract the electrons. Exactly what Br plus 1 wala hai. It's going to attract the electrons. Step number 2 is it's going to bond with the carbon atom. So this thing over here ये जाता है and it eventually bonds with the carbon atom. तो गिर गया कार्बन. अच्छा, तो वो जाके इस कार्बन के साथ it goes and bonds with it. There's an H that's already there. So when it bonds and not only it bonds, it basically pulls an electron out of carbon. So carbon's electron cloud or benzene's electron cloud is now going to be, it's now going to be partial. ठीक है, so it will be missing on that carbon atom because यहाँ वाला जो electron था ना, this got taken up by NO2. But that electron is going to get returned. How is it going to be returned? Because the H is going to lose it. So यहाँ पे जो H है ना, it's going to give the electrons back to the carbon atom or back to the benzene electron. Where would H get the electron back? HSO4 -1 ion was produced. That HSO4 -1 is going to come and pull the H out. ठीक है, तो finally क्या होगा कि the benzene electrons will become complete. The H will leave. And that H will leave and react with HSO4 -1 to form or regenerate the catalyst. So this is step number 1 and this is step number 2. Exactly these steps, which we just did in electrophilic substitution. That electrophile comes in, pulls an electron out. The H then gives the electron and leaves. So that's it. That's nitration of benzene. ठीक है, और ये उसका mechanism है, which I'm going to highlight. Okay, this is again something that you got to memorize. ठीक है इब्राहिम, मेरा ये सब क्लियर है? कासिम क्लियर है?
Yes, sir.
Yes.
तो हर दफा electrophilic substitution is the same. Now these are the three main electrophilic substitution reactions. इसको भी highlight कर लेते हैं. Those are the basic conditions for the reaction. ठीक है, तो you need to remember electrophilic substitution. You need to know the summary that there are two chlorination and bromination reactions. ठीक है, FeBr3 or AlBr3 or FeCl3 or AlCl3 are a catalyst. और फिर यहाँ पे you need to know that nitration happens in the same way, except कि nitration में remember this that mechanism में ना, it's the first equation that's also included, that the electrophile gets produced. ठीक है, and then that electrophile which was produced, it comes and attacks the benzene. And again, you have to produce the electrophile because the polarization of benzene alone is not enough, which is why you have to add sulfuric acid ताकि polarization हो. Otherwise, polarization is very, very weak. ठीक है, तो ये clear है main electrophilic substitution reactions. अब इससे आगे जो होगा ना, there's going to be a lot of variety to it because we just did the electrophilic substitution of a simple benzene. A lot of benzene compounds are not simple benzene compounds. They are derivative compounds that they have a benzene, but they've got lots of other stuff attached to them, to the benzene as well. So electrophilic substitution will have a lot of variations. So we'll discuss those variations. फिर वो नेक्स्ट क्लास में करते हैं, ठीक है? ठीक है भाई कासिम, मेरे इज दिस क्लियर?
Yes, sir.
Yes.
तो बस नेक्स्ट क्लास में फिर कंटिन्यू करते हैं इसको, ठीक है?
Okay, sir. Allah Hafiz.
ओके, अल्लाह हाफिज।